applications from science and stats. There's not really any notes with this. There'll be like a teeny tiny little bit when we get to the stats part. But we're skipping your favorite number.
How dare you?
Find the work done by the force of F of x newtons along the x-axis from x equals a meters to x equals b meters.
I'm okay. I just smashed my water bottle against my tooth.
Ow.
Yeah.
Is that why it's a little crooked?
Which one?
Yes.
Because, I mean, I know one of them's crooked, but I don't think it's the crooked one that I did. It was like, you know, like how you have those two front teeth? They're like the big
All
ones.
I want for Christmas is my two front teeth.
Yeah, I hit the right one.
Oh. Yeah. It's got a little chip out of it.
I mean, it hit like the center of it, so I don't see how that would have happened.
I'm messing with you, Josh. It's okay,
I mean,
Virginia. Your study buddy is okay.
I mean, I wouldn't be surprised if there was a little chip out of it or something. Oh, it's doing the thing, isn't it?
Huh?
I really wanted to see what it would say.
It wouldn't solve that.
It would just be like, what are you trying to do to me?
And it solves everything in radians, which I mean for our sake is fine, but. So basically, we're integrating this from 0 to 10. Not really anything crazy. So we have the integral from 0 to 10 of e to the sine of x, cosine of x, dx. Now, I'm going to go ahead and split this. I don't really need to, but I'm going to just because. So the integral from 0 to 10 of 2 dx.
Yeah, I was wondering what was going on there. I thought you forgot to write the plus 2. But no, it was all on purpose.
The main reason I'm splitting it is because I'm going to be using u substitution and I just don't want it to get confusing. But at the end of the day, I know how to integrate too, so I'm not that worried about it, but that's, whatever.
Wait, why would we use substitution?
Because do you know how to integrate this?
It is, so it isn't just e to the sine of x?
But this is being multiplied by the cosine of x. So the derivative of what's going to give me this?
We're finding derivatives or antiderivatives?
We're finding the antiderivative, but I'm saying the derivative of what would be equal to this?
Hold on.
I'm not saying that you can't do it another way, but u substitution will make it easier. You won't even have to think about it.
Let's just go with the u substitution.
Okay. Let u equal the sine of x, because the derivative of sine of x is what?
Cosine of x.
Cosine of x dx. So I have that in there already. Obviously over here, I'm just going to work this down. Why is this, not clear? What is happening? Wait, okay. So now I have the integral from 0 to 10 of e to the u du. Plus, I'm just going to copy the integral down. I know I can do that really quickly, but I'm just going to. So now what's the antiderivative of e to the u? Yes! E to the u. Evaluated from 0 to 10. Obviously, I have to substitute back.
So we could have just done it the way I was thinking, which was just e to the sine of x. So we're
Yes.
doing this step for Virginia.
I'm doing this step because you probably would do this a lot faster than the other thing. Plus, what if this wasn't positive cosine?
Then I would use the U substitution.
Okay, so I'm showing you how to do it in
Yeah.
case, because it won't always be like this. And antiderivative of 2?
2x. Wait, so if that was negative cosine, couldn't we throw the negative out front with the integral?
What if it was 3 cosine?
Then the 3 was already there.
Or what if it was 3 sine of x?
That's a thing to
I'm just saying.
do. Yeah.
So this is e to the sine of x evaluated from 0 to 10 plus, this would be 20 minus 0. 2 times 10 minus 2 times 0, just in case. So I've got e to the sine of 10 minus e to the sine of 0 plus 20. What's the sine of 0?
0.
So what's negative e to the sine of 0?
Negative 1.
So I end up with e to the sine of 10 plus 19, or we would have to do this in our calculator, specifically radian mode. And we would get 19.6 joules. This is a work problem.
That's
And just for reference, because we didn't really put this,
yeah, I was
but
wondering.
work is equal to the integral from a to b of f of x dx.
So that's why it was capital F.
Yes, because it's force.
Okay, I was wondering about that.
So the antiderivative of force evaluated as work.
Yeah, because I thought that like capital F meant antiderivative. Like, cause like lowercase f is like a thing, you know, starting with capital F, working backwards. So I was just a little confused, but I just went with it because.
So if you end up taking university physics, which is physics with calculus,
Ooh, fun.
this will be how you find work. So, but everything can be done with basic algebra, so it really irked me that I had to do it with calculus just because I was a math major. It was fine. Everything was fine. 5.
Ooh, it's an odd one.
It is odd. A leaky bucket.
Oh, that is really odd. It's a leaky bucket.
Yeah, hold on.
Imagine being a leaky bucket.
My mom was at the store for me, so I was trying to tell her yes to get that. Okay, anyways. The workers in example 2 was work done lifting. So they were lifting a leaky bucket from the ground.
Wait, what thing was it from?
Example 2. Just for you, Josh. Anyways.
About our number 2.
So basically in that example, they were lifting a bucket at a constant rate up and it was leaking the whole time. Anyways. So they changed to a larger bucket that held 50 liters or 490 newtons of water.
Was it supposed to be leaking?
I mean, is it supposed to leak? No. Is it leaking? Yes.
Okay.
Because it says, but the new bucket had an even larger leak, so that
Right.
it too was empty by the time it reached the top.
So these people need to find better buckets.
So this is like, kind of like if you've ever been to like, well, I don't know if a good example of this is like Great Wolf Lodge, like the bucket, but at Water Country in the new splash pad, which I mean, unless you have little cousins, you probably haven't been to the splash pad, but they have this thing where it's like water is filling this bucket, but it's dripping out the bottom at the same time. But the rate that it's filling is more than the rate that it's leaking, so it eventually causes it to dump all over you. Anyways, kind of that principle. By the time it's done and it reaches the top, the bucket is empty. So, assuming the water leaked out at a steady rate, how much work was done lifting the water to a point 20 meters above the ground? Do not include the rope and bucket. So we've got 400 and... Why did I write it in blue? Come on. 490 newtons of water.
Well, I mean, well, why wouldn't you write it in blue? Just out of curiosity.
Because I always write the question in black. 20 minutes, 20 meters above the ground. What is the work done?
We're using meters, not feet.
Now, I'm going to backtrack to example 2 to ensure that there was nothing there that we needed for this aside from that. Let's see. So that problem had said a leaky bucket weighs 22 newtons, empty. Oh, that was all. Oh, empty. It is lifted from the ground at a constant rate to a point 20 meters above the ground by a rope weighing 0.4 newtons per meter. That's why they're telling us we don't need to worry about that for this problem. It was relevant to the example, but not to this one. The bucket starts with 70 newtons of water, so we're quite a bit bigger in this case, obviously. But it leaks at a constant rate and just finishes draining as the bucket reaches the top. Find the amount of work done lifting the bucket alone, the water alone, the rope alone, and all of it together. So basically, we're doing the water for our problem. So I'm seeing if there's any relevant formulas that they need us to have before we get going. So in the example problem, they had given us a formula for force, and it was 70, which was the newtons of water. And then it was a 20 meter lift, so it was times 20 minus x over 20.
I
So-
thought you said like 20 minus x over 20.
Oh.
When I wrote it and looked up, and I was like, oh, that's not what she said.
So this is the proportion left at elevation x. Now, obviously, this could also be written as 70 times 1 minus x over 20, like that. And we obviously can multiply through if we wanted to, blah, 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 all the things. Now, for our situation, we're looking at it for an initial weight of the water being 490 newtons. So I'm going to be changing the 70 to 490 is really the only difference here. Then actually solving it out, obviously, thereafter would be the thing. But we need the integral from 0 to 20 of the force, which is what we're getting ready to write out. So we've got the force is equal to 490 times, I'm going to go ahead and use this second method, so 1 minus x over 20, which if I multiply that through would be 490 minus, let's see, the zeros would cancel, so 49x over 2. So that's what I'm going to be integrating now, then from 0 to 20. So I've got the integral from 0 to 20 of 490 minus 49x over 2. Or maybe I'll do 49 over 2x instead, just for the sake of seeing it. Now, the main reason for me choosing to write it this way is because integrating will be easier in this form than in this form. I would end up having to multiply to integrate anyways. And obviously, we've got dx here. So, this would be 490x minus 49 over 4x squared, evaluated from 0 to 20. So I've got 490,
So technically, would we have parentheses around those things before the evaluated at thing? Or
I mean, you can. I don't normally put it. I just know that everything's getting evaluated at that. But if you wanted to, I mean, you could.
it's like,
Technically, same kind of thing up here. You can put it here. I just know that it's not that. So it's like, at the end of the day, it doesn't make that much of a difference. What they're really looking for in the exam is that your final answer's right. They're not really looking at your work unless,
will they still give you like partial credit
for some things, yeah.
if,
Some things they'll say if you got it to this up, like probably if you set up the integral correctly, they'll probably give you points. But then you got your final answer wrong. Like they give you points for different things that they see along the way. And so depending on that will depend on how many points you would get. But yeah. So 490 times 20 minus 49 over 4 times 20 squared. And then I'm just going to put minus 0 because all of that would be 0. And what just happened? Oh, there we go. I was like, something is not right. Is that what you got? Okay. So there's our joules of work done there. Now, probably good to go back and look at like what would happen if we were looking at like the rope, the bucket, all that, but that's just in the example that they gave you. That's not part of this problem, so they don't even tell us that information. It's a new bucket, so we don't even, but it would be worthwhile just going back to look, especially for the one that's like adding them all up and stuff. Now, although adding them up is just adding them up, so the other stuff so that you can add them up. Yeah. Let's see. 6. Oh, a leaky bucket continued.
so is it
Oh.
the same bucket or did they patch it up?
The bucket in exercise 5 is hauled up more quickly, so there's still 10 liters of water left when the bucket reaches the top. How much work is done lifting the water this time? Oh, 10 liters is 98 newtons. So we've got 6. We've got 98 newtons are left. notes today. I was about to be like, I am not prepared. I do not. Okay.
I wonder if they would be prepared.
Well, my computer was like glitching this morning, so I like couldn't do anything, and I hadn't printed their college algebra quizzes yet, and so I was like, literally did it from my iPad, cause like, and I couldn't put in attendance or anything. I had to like restart my computer. It was the whole thing. Anyway, so then I was like, oh no, did I forget one in the midst of all of that? So there's 98 newtons left at 20 meters. So now I'm going to have to basically find an equation for this. So at 0, there's 490 newtons of water. I guess it's 0 meters. And then at 20 meters, there's 98 newtons of water. So I'm going to treat this like an XY pair, find the slope, and then I'm going to use point slope form to write an equation of the line. It's been a hot minute since we did point slope form. So I've got, it doesn't matter, obviously, if we do y2 minus y1 or x2 minus x1, it's going to end up giving us the same thing. So I'm just going to do 490 minus 98 over 0 minus 20. So we've got 392 over 20, and that whole thing ends up being negative, and that reduces to 19.6. Now, if you want to leave it as a fraction, you can, but I would probably just go ahead and convert it. So then y minus 490 equals negative 19.6 times x minus 0. And so then I get y equals 490 minus 19.6x. So now I'll integrate this from 0 to 20. What happens when I integrate this?
Things. So that would be like 490x minus, I want to say 9.8x squared.
Yep. 0 to 20. So I got 490 times 20 minus 9.8 times 20 squared minus 0. Is that what you got?
Yep.
Awesome. Alrighty, getting into stats. So here's some notes here.
Hey, stats.
We may have to finish this up the first few minutes of physics before we have to leave. So normal probabilities.
Wait, it's just probabilities? Just probabilities?
Sort of.
Imagine trying to find a confidence interval with confidence.
Oh, it's a thing. Now, the probability density function.
Ooh, that's
Whoa, I don't know what that y was.
it's like
It was a,
deformed.
yeah. Density. You know what?
That was a density.
It was like density. Okay, PDF.
You know, I don't think I ever realized what PDF meant until just now.
Yeah, probably not. The function f of x with domain, all real numbers, such that f of x greater than or
That's a
equal
lot
to
of
0
shorthand.
for all x and the integral from negative infinity to positive infinity of f of x dx is equal to 1. Then the probability associated with an interval from a to b is the integral from a or to b, of f of x dx. Now the normal probability density function meaning normal PDF, as we would have called it previously.
Lack
For
of density this time.
Gaussian curve
Not gonna lie, it looks like you wrote normal Holf.
it says PDF, Josh.
Yeah.
For a population with mean mu and standard deviation sigma is f of x equals 1 over sigma square root of 2 pi times e to the negative x minus mu squared over 2 sigma squared. Now, we know the 68...
Is that 1 over sigma root 2?
It's the
Pi or
square root of 2 pi.
Okay.
We know the 68, 95, 99.7 rule for a normal distribution. Do I need to write that out, or do you remember that?
What did you say?
The 68, 95, 99.7 rule.
And like,
Do I need to draw it out, or do you remember it?
I don't think you need to draw it out. Is it like how many standard deviations it is?
Yeah, that within one standard deviation, it's 68% of your data, 2 standard deviations, 95, so on and so forth.
Yeah.
Okay. Just as a refresher, a normal curve is a bell curve the mean can be denoted average.
If you're mean, you're demoted.
Average. Can't spell average either.
Can't be as bad
Mu
as-
or X bar. I put an extra E in average.
Where was the after the
Average.
average?
It's the French version.
I thought that was the southern version.
Standard deviation is the scatter around the mean.
How many more of these are there?
What?
Because I only have 2 more lines for listing stuff.
Just one more line.
Oh, nice.
And then just remember the 68, 95, 99.7 rule for normal distribution.
So,
Since y'all both had stats, the main reason I don't need to write that all out.
so we can denote standard deviation with sigma or just S.
Yeah. Usually one is for the population and one is for the sample and stats, and more or less that's the same thing here, like the same with mu or X bar.
Yeah,
But-
I think I at one point didn't know which one would be used for what.
Yeah.
Probably figured out which one would be used for what. I feel like S would be used for the sample though. Because S for sample.
All right, 28. Find the probability that a clock stopped between 3 o'clock and 6 o'clock.
It would be really fascinating if like Virginia figured out a way to use calculus on the stats exam.
Probably make it harder because we're not doing that much with it. All right, so did they specify AM or PM?
No.
So they do not. So that means how many times a day can this happen?
Well, we have 3 a.m. to 6 a.m., 3 p.m. to 6 p.m., and 3 a.m. to 6 p.m.
Okay.
Or are you only thinking of the first 2?
Pretty much, yeah. Anyways, okay. Well,
Did
f
that-
of t,
Did that make things confusing?
potentially, but yeah, it's fine.
Did I raise a valid point though?
Yes, you did. But a clock doesn't have AM and PM, so it really can only happen twice that it is in that range, though.
Yeah.
So, it would happen twice in a 24-hour period, or 1 out of 12. For 0 less than or equal to t less than or equal to 12. And otherwise, it's 0. This is some crazy math about to happen right here. The integral from 3 to 6 of 1 over 12 dt.
Wow. That's like actually.
So this is 1 over 12t evaluated from 3 to 6. So 1 over 12. Now this is a constant number, so I can just multiply that by 6 minus 3, meaning 3 over 12 or 1/4. So the probability that it stops between 3 and 6 is 1/4. And again, you really don't need calculus to figure that out. Because in total, that would be 6 hours out of the day. 6 out of 24 is 1/4. We really don't need calculus to do that. But we can use calculus to find it.
So it's just to prove the point.
Yes.
So what is this, spike math?
Pretty much. Test scores. The mean score on a national aptitude test is 498 with a standard deviation of 100.
It's a pretty big standard deviation.
What are y'all doing in government?
Wanted to say about this.
Like right now?
I think so.
I'm going to finish this really quick. All right. A, with what percentage of the population has scores between 400 and 500? And I say that because we're just going to use NINT to do this.
Wait, probably tell this to do.
You can't possibly do this by hand. You don't know how. So we would have, using the formula here, hello, using this, we would do 1/100 times the square root of 2 pi times e to the negative parentheses x minus 498 squared over 2 times 100 squared. This is f of x. And then we would just run NINT from 400 to 500 of f of x. And we would get that value, which I'll just tell you for the sake of time would be 0.34 or 34%.
Well, is there one kid here today? Yes, there's one. They live at 245, right?
This is the most unathletic.
Tennis court is right there. You should.
Then part B,
Oh, but wait.
there's 300. Why do you think I just wrote A? There's 300 test. Guys, I'm still teaching. There's 300 test takers. How many have a score over 700?
I mean, I'm just gonna have a
So
wild guess.
the highest, zip it. The highest that I can have is a 900. So I'm gonna have NINT from 700 to 900 of that same function f of x. We can type it in later when we come back and finish this, but
So would it be f of x dx?
yes, technically speaking, I'm just not writing that for the sake of time. But yes, it would be 0.022. Now, that's for one person. There's 300 test takers, so I would do 0.022 times 300. And that would end up giving us 6.6 test takers. Would get that score. Since I didn't write the dx up there, I'd go back and add it. Okay, problems, and then that's it. 3, 7. Hold on, am I missing something? 27, 29, and 31.